In this video, we'll talk about complex numbers and the complex number system. So before we get into complex numbers, let's kind of take a zoom back and look at just numbers in general. So the first number system was the natural numbers, which we usually designate with a double-legged N. And these are numbers like 1, 2, 3, 4, so on and so forth. All the positive whole numbers. Then our next number set is the whole numbers. It doesn't have a fancy symbol, and it basically just adds in 0 to the natural numbers. That concept of 0, the reason they designate it as a separate set is because it took a long time for human beings to develop a concept of 0. Our next set deals with the integers. And that would be, we're looking at negatives. So we have the negatives of all the whole numbers, and the whole numbers as well. Now you might be thinking to yourself, okay, I could think of more numbers than the integers, and there are. What about a half? What about 2.5? All those things. So there's another one called the rationals, which they designate with a weird Q. And that would be any number that I can write as a fraction involving only two integers or a terminating or repeating decimal. So like 1/2 is 0.5, or 1/3 is 0.3 repeating. Both of those would work. However, we're still missing numbers like pi and e, the square root of 2, those kinds of numbers. So we have numbers over here called the irrationals. That are kind of in their own little bubble. So like pi and the square root of 2, and we'll talk about a number e eventually. So we have our number system. For the real numbers, we're combining these two because there is no overlap between them. So if we combine the two, that's where we get the real numbers, which we designate with a double-legged R. And then, if we take it a step further, then we might be thinking, okay, what numbers do I not have? And that might be a bit of a difficult thought. However, what about the square root of a negative number? Can I do that in the real system? The answer is no. I don't know what times itself makes a -1. Anytime we multiply a negative by a negative, it makes a positive. So this is where we have the imaginary numbers. And these are kind of the foundations for making the complex number system. So if we consider the real numbers with the imaginary numbers, this is where we have the complex number system. So basically, the complex number system is founded on this idea that, okay, what if we could take square roots of a negative number? So we say the square root of -1 is a lowercase cursive I. That's it. We're just talking about what if. What if we could take a square root of a negative? This is what it would be. And this term, imaginary number, it just kind of is what it is. It's the historical term. It's strange. But this is what it means. Now, the cool thing about I is you can pretty much treat it just like you would a variable. You take your square roots just like you would in any normal number. You just stick an I out at the end of it if it's negative underneath the radical. Now, a lot of computers and a lot of calculators won't know what to do with it, but that's okay. The only difference with I is if you start looking at powers of it. So if you look at I squared, well, this is technically the square root of -1 times the square root of -1, which makes it -1. If you have I cubed, well, technically that's I squared times I, so you're just going to have -1 times the square root of -1, which is -I. If we look at I to the 4th, Well, we're going to have I squared times I squared, which is negative 1 times negative 1, which is positive 1. And then I to the 5th, well, we're just going to have 1 times I, so just I. And then it repeats. It goes back up to the top, and then back down. So it repeats every 4th term. This is the only difference, so if you see I raised to a power, just think about what that's really meaning. If you just see an I, you can just treat it like a variable. So let's do a couple of examples. We're not going to delve too heavy into complex numbers. They are useful for some complex mathematical models, but for our purposes, we just need them to be able to solve quadratic equations. So in this case, we're looking at the square root plus or negative, or plus or minus, of negative 9. Now, normally we could not take a square root of a negative number because what times itself makes negative 9. The idea here is we just say, okay, ignore the negative sign for a second. Let's just look at the 9. What's the square root of 9? It'd be 3. So I have plus or minus 3. Now we reconsider the negative I. That's it. We just do our square roots as normal, put an I at the end. That's how we take a square root of a negative number. And since it's all just kind of hypotheticals, this is okay. Now let's do something a bit more complicated. Let's say we have an expression and we're dealing with complex expressions. So if we're looking at this, we are trying to simplify this expression. Now for most of the intents and purposes, we can treat I just like we would any variable. The only difference lies in if we have to take it to a power. And then there's some shortcuts we might be able to take. So we're going to go ahead and we're going to smiley guy this out, or FOIL, or double distributive, whatever your preference is. So we're going to take 5i times 3i, which is going to be 15i squared. Negative 2 times positive 1 is negative 2. Negative 2 times 3i makes negative 6i. And then 5i times 1 is just 5i. I can combine the negative 6i and the 5i just like I would any other variable. So I'm going to have 15i squared minus I, because there's only one I left, minus 2. Now I'm almost done here. I'm looking at this power of 2 on this I. Now we talked about this a little bit. This expression is negative 1. So 15 times negative 1 minus I minus 2. So really this boils down to being 13 minus I. And this little difference here is the only difference between I and any other variable. If we're taking it to a power, things get a little weird because technically it represents the square root of negative 1.